Hello and welcome to the AdNug podcast, the podcast for the Adelaide.net user group. I'm your host, David Gardner. This is a recording from our August 2024 meeting, the different ways you can join your code together with Calvin Fong. And now, over to the presentation.
So I guess I'll start this talk by talking about who I am. And I've recently started a consultancy with a friend. We are very new, and pretty much if anybody wants to catch up for coffee, to give us advice, or to talk about programming, we're very, very keen. The other thing is this talk is going to cover some topics that are quite new. So my goal isn't to convince you to immediately employ all of these sort of techniques when you start your project. Just not going to go away and do that. But it is to plant a seed that maybe when you're bashing your head against a keyboard, there might be a better way, and maybe when you run into that, maybe you'll start looking into these things a little bit more. So based on the title of the talk, it's mainly about, you probably guessed that it's mainly about modularity. So the first step of talking about modularity is to first define what modularity is. Two quite common examples are Lego and jigsaw puzzle pieces, and they are actually very, very good analogies for what modularity actually is. So what I'm going to look at here is two individual Lego bricks, and I can safely join those together using these little knobs at the top. When I join those two bricks together, I get a slightly bigger brick, and then I can use that brick and just treat it like a slightly bigger brick. Here is an example of a bin. It is comprised out of a whole lot of smaller little bricks, and it becomes a slightly bigger brick. When I look at this bin, I don't care what it's made out of. I only care that it is a bin. And I also don't care where I place this bin in my overall architecture. All I care about is that it is a bin and it joins at the bottom. Same with this tree. I don't care that this bin exists at all, and I also don't care what it's made up of. All I know is that it is a tree, and it joins where it joins. So the idea is I can understand a brick or assembly without needing to consider the rest of the world. Same with jigsaw puzzle pieces. The knobs allow you to safely join two jigsaw pieces together, and I can treat this very, very big combination of jigsaw pieces as one big jigsaw piece, and I don't really care where it is joined together. Okay, that was a very thick line. There we go. I don't care at all. I can just view it as one big piece, and I know where it joins. I also don't care about all of this other stuff going on. I can treat it as one big piece, and all I care about is that it joins at these individual locations. Again, I can understand an area without having to consider the rest of the puzzle. So the general idea of modularity is three things. Firstly, you have knobs that allow you to join two pieces into a bigger piece. I don't care what big pieces are made of. And three, I don't care how pieces are used. So can anybody guess what the pieces are in programming? It's pretty close. So the two things we need to identify are the pieces and the knobs. Anybody want to take a random guess at? Functions is good. And then, yes, calls, it's the types, right? The types of your functions are the knobs that allow you to join them together. So I'm going to give you an example. Here are two functions. One takes an integer and outputs an integer. It's called add4. You can kind of guess what it does. The other one takes an integer and divides it by 3 to output a double. Can anybody guess how you would join these two things together? It's not a trick question. Yeah, correct. So if we look at this, I don't know why I decided to do this, but here it is. You just join them together by putting the outputs of one function into the inputs of the next function. What's beautiful about this is that, again, I don't care. Once they're joined together, I don't really care about how they're joined together, right? It's just treated as one big box. In the same way as these puzzle pieces join together into a slightly bigger puzzle piece, and you don't care about how they're joined together, you don't care about how this function is joined together. All you care about is that it takes an integer and outputs a double. So let's go with some other examples. What I'm going to ask you now is, what would the bigger box look like when I join these two boxes together? So what would the inputs be? Correct. The inputs would be two fiancés, and what would the outputs be?
A couple.
Yes.
Sort of.
So we take these two things and we just stack them on top of each other, and we get a bigger box, right? It took two things that had one input, and it created something with two inputs and two outputs. And again, we can just hide this away, and bam, we have a bigger box.
Question, is fiancé actually spelled differently?
Yes. So this is something that so the female is the double E, the male is the single E.
Huh. More you know.
Yeah, there we go. Crazy. Finally, we have another slightly more complicated example. How would you join these two together? What are the inputs and the outputs of the bigger box? We'll start with the inputs.
Put white and egg as an input. Sugar and egg.
Yes, correct. Sugar and egg as an input, and the outputs?
Yolk and meringue.
Yes, very good. So, we have this idea. It joins together by just chucking the whites together and then just pushing all of these all the way through, if that makes sense. But again, you don't really care that much about how these things join together. All you care about is that it takes egg and sugar in and outputs yolk and meringue. So again, the idea is that you can open and close these functions, and also these functions translate very easily into code. Here we go. We have find a groom, find a bride, and we can just do husband, wife. Find a bride is the output of husband. Yes, that's correct. Find a groom is the output of wife. That's correct. Which means that the outputs are, again, husband and wife, and I'll get married, and the inputs are fiancé and fiancée or fiancé or whatever. And you can close this function, just like you can close the box. And again, all you care about is the externals of the box. And here it is. It's closed. You don't really care about what's going on in the middle. So the general idea about this is that you can use this technique to consider your program as a whole and make your program, in essence, what this definition of modularity is. You might have another definition of modularity based on how you programmed in the past, but I'm using this definition of modularity, and my job today is try to convince you that it is a useful definition and that maybe you want to try it out. So here is a recipe for baking a lemon meringue pie. You're probably very used to a recipe on the left, but you can kind of see that this recipe on the right is also somewhat useful. You might be able to read it and be like, well, I'm going to separate an egg into a yolk and a white. I'm going to add some stuff together, get a lemon filling, and then I'm going to fill the crust and add meringue. And at the same time, I can also, make a meringue and, do that together and get an unbaked pie. And then I can zoom out. And I can be like, well, that entire thing fits into this big box here. I actually don't care about how it was implemented. There's just some inputs and some outputs. And I can zoom out again, and this is called make and bake lemon meringue pie. And I take some inputs, does some outputs.
Are you going to make a pie tonight?
No. There's already so much pizza. And here is the relevant code. And as you can kind of see, it kind of just looks the same. Like you have something that separates the eggs into yolks and whites. You have something that makes the lemon filling, takes some inputs and returns some outputs. It all just looks the same as the diagram. But one nice thing about the diagram, for example, is that you can see that these two processes can be run in parallel. So before I get into the complicated ways that you can join code together, I'm just going to answer the question that you guys are probably asking, which is, wait, but why? And so what I'm going to say is there's been this popular movement towards test-driven development, which is and what has happened is people have really found that if you define the outline of your problem really well, then it makes it easier to implement the code, right? So you define like a sort of wireframe, and then you just make sure the tests pass. And then you define your problem, and then you make sure the tests pass. My claim is that using types is like test-driven development, but on steroids. So what's going to happen is the big advantage of types is that they are composable. So when I have two small blocks, I can join them together in a big block, and I can use the information that these two individual smaller blocks are working to guarantee that the larger block is working. But with tests, you'll often find that if you test two individual components and then have a component that joins those two components together, you still have to do a whole lot of tests. In fact, if you had 3 cases on the first test and 3 cases on the second test, you often have to do 9 cases to cover every possibility on the outer layer. And this just gradually gets worse and worse, and the commonly adopted approach is that you kind of just rely on your middle test to actually be fine. And then you're kind of just like, well, I'll just test, 2 of the 9 scenarios and call it a day. And again, this approach is just like, hey, I've got a missing puzzle piece. I'm going to write some code to fill in the missing puzzle piece. And you can kind of see how that would work with this approach. You just have this question mark, question mark, question mark. It defines the inputs and the outputs. And then you just have to write code to figure out how to implement that. In fact, this method is so easy that this is generally how I program nowadays. I just write the function signature into ChatGPT or Claude, and it outputs a fairly sophisticated function that would take like a few minutes to write myself. And that leaves me able to just think about the structure of the problem I'm solving, rather than spending 5 minutes thinking about the structure of my problem, then 5 minutes coding, then 5 minutes thinking about the structure of my problem, then 5 minutes coding. It's all about thinking about the structure of my program. What's great about this is that it doesn't really matter what language you use, right? If you can define your problem via its structure, like all of these sort of LLMs can just kind of fill in the blanks for you. So I've managed to describe a problem in Haskell, a language that I barely know, and it's just come up with a whole lot of functions that I didn't know existed and chained them together to create this quite simple sort of function. And this was for a project that I just joined, and like within a couple of hours I was productive. The general idea is that you want to let the computer help you. So what's happening is you're telling the computer stuff, and if you get the order wrong or you do something bad, the computer's going to give you this nice, friendly red underline. The other end of this is that if you don't tell the computer what to do, it can't help you. So here's this function. It has a function signature void do stuff, and it takes an input, and the question that the computer's just going to ask is, what's in the box? Has anybody actually seen 7? Wow, that reference fell extremely. Okay, that is very disappointing. There's a scene where Brad Pitt just screams, what's in the box a lot, because there's something bad in the box. Okay, I thought that scene was more famous. Anyway, I should definitely have hidden this. Okay, which one of these 2 function signatures? So we can use this to guide our sort of coding principles. Which one of these 2 function signatures is better?
The second one.
Anybody else want to guess?
What are you trying to do? The first one.
So, okay, who said the first one, and then explain it?
Oh, yeah, just what you do something.
Yeah.
So he said the second one wrong.
So in this case, we can see the implementation of the function. Which one describes the function better is maybe a better question.
It depends on the limit of the number.
Okay, somebody has said that.
Exactly.
Conceptually, I'm going to claim that the first one is better, because the first one doesn't force the computer to consider decimal points. And as you can see by the function, there's no possibility for there to be decimal points coming out of this function.
Yeah, when you have a very big one. Yeah.
I should have changed my example. Conceptually, I guess, I don't know, decimal? I don't know.
If you assume no overflow,
that's fine. I mean, the point is you want to notify the computer with what it needs to consider, And in this case, we only want the computer to consider integers as an output of this function so that it can chain together with other functions that accept integers. And so if you give the computer very, very specific instruction outlines of what your function does, it can start doing very amazing things, as we'll see later on. While if you give them pretty vague sort of instructions of what it is, then it's just going to be like, well, I'm working with a blob. All I can do is sort of give you a bigger blob. Yeah, exactly. I mean, this is probably the best example. It just returns something. Like, it does something, and you just have no idea what it does. Something that returns object is, also pretty gross. And you guys have probably seen functions that return objects and sort of bash your head against the keyboard, maybe? Yeah, because you just have to keep on reading in further and further into the function to figure out what the heck it does. So again, my goal here is not to be like, hey, this is the ultimate way of programming, blah, 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 blah. It's just to plant a seed that, hey, maybe if I tell my computer a lot of information, it's going to be really useful and help me out. So we're going to move into more complicated versions of composition. Here is a couple of functions. One takes an integer and gives you, I don't know, the first n Fibonacci numbers based on that. The other one takes an integer and converts it to a string. How do you join these two functions together? You are allowed to say it. I don't think you've seen this one before, right?
I've not seen this one before. You always need to be able to pass the function in, or use the two. They don't match.
Who here is familiar with link?
Do you have to go through every item in the list with that second function?
Exactly. There we go. That's actually exactly correct. Have you guys, a raise of hands, anybody that's used the select function in link? So the general idea is exactly that. You take the function, you apply it to every element of the list. And what that allows you to do is it creates this sort of two-dimensional box where you start with a function from A to B, and you convert it to a function from list A to list B. That's pretty nice. What's kind of gross about this is that your diagram becomes two-dimensional, which is really not fun. So essentially what happens is you flip this. I'll see if I can do it. Group these things together, and you kind of just, bleh. And then you put that there. That's the wrong one as well. Put that there. Bleh. And you put that over here, and then you put this one over here, and it kind of like joins together in a gross little way. Mathematicians find it easy, other people not so much. And I am one of those people. So we can do this little trick where we can just create a fancy box and just say, whenever it chains together with that fancy box, right, it's like this thing with circle thing that says list on the top, right? Then I'm just going to apply select to every function that occurs afterward. And this is exactly why link is so nice for people that use link, is that it just kind of has your regular function chaining that's super easy to think about and chains them together in a sort of fancy way. And what you end up with is this slightly different looking box where it's got curved edges and it says list at the end. And you can then chain that together with everything because, your computer knows that it can sort of combine things together. By just using select, it can combine it with the next thing and the next thing and the next thing, as long as string sort of match it, as long as the next box takes in string and outputs whatever. And in fact, you have this sort of link query syntax where you can just do that by just changing the symbols that you use very, very slightly. So here's an example where I had like a function that, worked without the list, and the other one is working with the list. And you can kind of see that they're kind of just the same thing. Like, this has from here, this has var here, this is in here, this is equals here. But other than that, they're just almost identical. And this is the beautiful thing, right? You can start adding complications into your code, but you're still kind of visually thinking about the exact same thing. We're going to have another example. This again uses Fibonacci and outputs a list, but this time we're going to get the prime factors of the output number. How do you chain these two together?
Same way, but with a filter operation.
Correct. What method is hiding under here?
I might need a C# person, so I don't know.
Like, is it another link operation?
Yes.
Is it where? Or contains?
Well, so the goal is like just going for distinct factors of Fibonacci, then it would just be like a distinct type operation.
We don't need distinct. We just want all of the like factors of the list.
Select.
Hey, we got it. Select many. Takes a to a list B, returns a list A to a list B, with an asterisk here because that's actually not the function signature of select many, but it's semantically the same thing. And again, you can kind of see that this joins together, and you get a better thing. And it's just like, well, all this is really doing is applying select many at the right spot. And again, like the link query syntax just lets you do that. So again, you have the from n in, blah, blah, from factor in, and there equals. You're just changing symbols, and you get the exact same code. And so this is kind of a nice thing. You have this very, very simple thing. You add something complicated. You still have this very, very simple way of looking at it. In fact, let's imagine a problem where we now want to consider the time it takes to bake a lemon meringue pie, right? Here are all of the individual operations, and again, we're just going to add sort of a little symbol at the top right and say, hey, we've got some extra things to do. So this is saying, hey, well, this takes 2 minutes, this takes 10 minutes, this takes 15 minutes, this takes 4 minutes, this takes 4 minutes. If we add them all together, we get 35 minutes. I did the maths. You don't need to check that, I hope. Yes. So this is going to be quite difficult to take a guess at, so I'm just going to keep on going. The solution to this is that you, again, help the computer help you. So you define some sort of way to tell the computer that not only are you outputting the information that you had before, but you're also outputting the time it took, the duration, right? And you put that into a struct, and then you define yourself a select many, right? So if anyone wants to take a guess at what select many does by reading it. This is hard, yeah. Conceptually, what do you think would happen if I join this box with this box? What number would you expect on the top right?
14.
Correct. Select many just adds the two numbers together. That's all it does. It applies the operation and adds the two durations together to get a bigger duration, as you can see here. And then you have a bigger duration. Select just applies a thing and keeps the same duration because the second box doesn't have a number. So what are you going to add? You're not going to add anything. You can add 0 if you want. So by defining select and select many, we now open ourselves up to absolute magic by the C# team. You can now just solve this problem by just replacing every version of from, every instance of there with from, and every instance of equal with in. And the C# compiler will just do magic because it recognizes that you have select many and select, and it will just automatically do this and chain this together, and you will get a result of an unbaked pie plus a duration of 35 as your output for this function. Again, the idea is you could just, do this all the time. Like, you haven't made your problem more complicated. You've attached the complication into your type and then let the computer do this. What's extra beautiful about this is that, again, conceptually, when you look at this diagram, you're like, well, if I had 2 people baking a lemon meringue pie, wouldn't I be able to do them at the same time? So these two, this dotted box, what number would you expect on the top right of this dotted box if you had the ability to do 2 things at once, if you had two chefs at the same time? Yes. So what's happened here is we can first grab this, turn it into a box with 14 at the top right, which is this function over here. And then what we do is run stuff in parallel, right? And this time extension stop run in parallel will just run these two things in parallel, and we'll just take the larger of the two numbers. And so what we can do is we can solve a complicated problem very, very easily with minimal changes to our code. So what I want to say is, what happens if you don't tell computer, nice, then you take in you're just taking an egg and separating an egg. What I've done, all of the code examples here, by the way, have been written by ChatGPT, and all of the code examples you're about to see have also been written by ChatGPT. So here is what happens when you want to do this in sort of a different way where you're not telling the computer what's going on. So here's an example of this simple scenario. You just have this field, that called total duration, and then whenever you have these operations, you just add to the total duration. And what you get is something pretty nice. You just do these operations one by one, and you get a pretty nice result. But when you start doing that with a more complicated sort of situation, ChatGPT definitely fails. It fails miserably. So here's an example of how it fails once. Here's an example of how it fails twice. I believe this outputs it takes 90 minutes to bake a pie or something like that. This one kind of works, but there's a little bit of sort of awkward thing. I think there was actually a bug in the previous code, and this was the one that uncovered that bug. And then once you fix that bug, it stopped working. And here is the solution that actually does work. And what it does is it just rewrites every single element to not include the time, and then moves the responsibility of how long it takes to separate an egg into the make two people recipe. And so what you have to do is you have to add these in. The responsibility of how long these operations takes no longer belongs to the operation. It's now belonging to the recipe on the outside. And so you end up with this somewhat complicated code that is not very reusable, and you now need to probably know that each egg takes 30 seconds to split in every single recipe you ever build from now on. So that's kind of a neat trick that you've kind of seen. How useful is it? There are libraries, and it's probably the top library I recommend for trying this stuff out, called LanguageAXT. Each of these lines is a different way of doing this. They have the ability to do this for optionals, so nullable types. They have the ability to do this for errors. They have the ability to do this for things that throw exceptions. They have the ability to do it for validation. They have the ability of doing it for reading state. They have the ability to do it for writing. They have the ability to do it in sort of a client-server architecture. I don't actually know whether this one uses that trick. Maybe it does. And all of these different sort of arrays and stuff like that obviously have the ability to sort of use the from the link syntax, because they're all enumerables under the hood anyway. So overall, this is a pretty neat trick, and I will show you how this looks in the code base in a real code base in the future, and what the development experience looks like. The second thing we're going to look at is unions. I like the cat, dog, animal example, so I use it a lot. I actually don't know what I did here. Okay. Let's say we have all of these things together. This is an impossible one to work out. Okay. We have all of these things together. I'm just going to show you what that looks like. So if you have a cat and dog, and you have something that inherits from a cat and dog, you can turn it into, if you have a function that takes a cat and makes a noise, and takes a dog and adds a noise, you can create a function that takes an animal if an animal is either a cat or a dog, and this big box, again, is just going to take an animal and output a string. So the trick here is that you need to define a type called animal, which is the union of a cat and a dog, if that makes sense. I think conceptually that's easy. It's only when you start using your programmer brain that it becomes difficult. And you can kind of see this here. This is what the code does. Takes a dog, takes a cat. An animal is either a cat or a dog, so you just switch on the dog or the cat, and you make the noise, and you either get woof or meow. Here is another example. You have a cat eat lunch, have a cat. dog, eat lunch, dog. And what I'm going to claim to you here is that if you do this, what's going to happen is your dog can turn into a cat. So if I define my animal like this, where I use inheritance, and I have a cat and an extends animal, I have a dog and it extends an animal, how do I write a function that has an animal eat lunch and still still guarantee that it is that same animal? I'm not going to. The only way to sort of give this up is to actually come up with an example is code, and I've written some code below to sort of show what that looks like when you actually use a different interface in C# to do this. But the general idea is that using it this way, you kind of get this annoying thing where it's like, well, what's in the box? Could be a cat, could be a dog, don't know. So the way you do this, right, is you define an interface like this. The interface says, hey, I'm going to have it's a generic type on T where T extends animal T. This probably looks pretty gross to you, but essentially what it means is that now I can define a public static abstract T, eat lunch T, and I know that if I put a cat in here, I'm going to get a cat out. I know if I put a dog in here, I'm going to get a dog out. And so this is what the sort of function looks like when you do it, when you implement it. So what you can do is you can just type animal dog here, press Control dot, it'll automatically create these functions for you, and then all you need to do is fill in these functions. What this allows you to do is start using some sort of thing like this, where you go, hey, I'm going to feed it and then make noise, and it's going to be able to work out what's going on here. So I'm going to eat lunch, it's going to update it, it's going to, I don't know, no longer be hungry, I believe, is probably it. Yeah, so the dog loves you more and is no longer hungry, and if it is hungry, it's going to feed you, it's going to ask you to feed it, otherwise it's going to ask you to pet it. So that's what's going to happen with the dog. What's going to happen with the cat is he's going to be like, hey, you are a mere human, and then it's going to get you to bow down to you and go meow, meow, meow if it decides it's not regal enough. You might be thinking, wow, this looks complicated and annoying and really completely unnecessary. This is the iNumber interface from the C# team. So the C# team uses this because it's the only way to write code that is composable and reusable enough that you can, because you need to tell the compiler what it does. This is, so almost as we go further and further into C# patches, more and more of these interfaces are being defined so that they can make sure that they can refer to themselves and not lose the fact that they are a dog when they run through these functions. So this...
Just saying that the type it is needs to implement that interface.
Correct. The thing that this really prevents you from doing is I could write public record cat extends animal dog here without that where clause, right? But with the where clause, you can no longer do that, which means the computer now knows that it's definitely a cat. Because otherwise what's going to happen is, imagine you're calling like some function on T, it won't actually know whether to call the cat eat lunch or the dog eat lunch at compile time. And so it's just like, well, what the heck's going on here? This is somewhat crazy. Finally, we have this concept called lenses. So how would these three boxes join together? What would be the overarching thing at the end?
Sanitized title.
Correct. What would the big box look like? What would its inputs be and its outputs be?
Input book,
Yep.
output book.
Hey, we got it. So if we join all of these things together into this big box here, we get an input book and an output book. You're going to have to use this duplicate function, which is really just going to give you two of the same object to do that. But then you can just join things together. One thing you might notice here is that actually it's almost as if this get and this, I guess it should be called set, not update. Let's call it set. This get and the set sort of work together to create a structure where I can create this thing from string to string and turn it into something from book to book. So that is what we have. Something that takes in a function from B to B and turns it into a function from A to A. And this is why it's called a lens, because the B is the thing that you kind of look into, and the A is the thing on the outside, if that makes sense. So the general idea is that you can create a lens by just providing a way to get from outside to inside, and then a way to set it by taking the original object and the new data and turning it into new data. This is very similar to sort of gets and sets of a class. I would say almost identical, but there are some niceties which we may or may not have time to go into. But this is what that code looks like, and it is quite simple code. It says, hey, I'm going to accept in a function from A to B. I'm going to accept another function from B to a function from A to A. And then I get this function for free, which takes a B to B and turns it to an A to A. And it does it like this. So it takes the book, gets the title, removes the swear words from the title, and then inserts that title into the book, the original copy of the book. A is, yeah, maybe I should have labeled them differently. A is the book, B is the string.
Okay.
So the general nice thing about this is that if I have a lens from A to B and another lens from B to C, then I can get a lens from A to C. And here's some code that does that for free. So all I'm doing is I'm just zooming more and more in. So what happens if I know this is in here, and this is in here, and this is in here, I can just go all the way in, write a function of only what I care about, and then zoom all the way out to the state of my entire application. And here's what it looks like in real life. I have some function called remove swear words. This was actually like 60 lines of code, or not quite. I think it was like 10 lines of code by ChatGPT. I don't know whether it's the most efficient way to do it, but whatever. Here's a lens from book to string, which again just takes these two functions. And then I can just write this function from book to book that I get for free by having this, just lifting this function up. So with these techniques, it's realistically, you will get benefits from this individually, you will get benefits from this individually, and you will get benefits from this individually. But you can write a full stack application by doing this stuff. I'm going to go through one or two examples of sort of what the development experience looks like when you start applying these techniques. So for this, I have a sample application. Essentially, the idea is, I wonder how this looks on your, yeah, it's enough. It takes in some bank transactions that I've generated, I hope, and it's not my real bank data. Yeah, this looks generated. Yeah, I don't think I've been to the gym in a while. And then it takes them in and then outputs, some nice graphs. Again, spreadsheet surgeons, this was originally a spreadsheet as our scoping document, but the general idea is that it will just output a whole lot of different graphs with the input of these sort of CSVs coming from different bank accounts. So here's one from ANZ, there's also one from Bank SA, so on and so forth. And so we have some application that does this by reading the descriptions and trying to categorize it using, I think it's ChatGPT again. So it just gives it a category, and then those categories can be sort of categorized, I guess, and you can be like, oh, I've spent, that was an expense, right? So I spent a lot of money on groceries, or that was a discretionary expense. I've spent a lot of money on restaurants and takeaway. So it's actually quite a normal sort of budgeting sort of software that you can see all the time if you had to plan for a kid or a wedding or a holiday or whatever. And the general thing is that it will dump this data into here, and then and here and here and here, and it will output these tables. So what you might have noticed in this bank data, though, is that there are these little, ASDF 23 little errors that I've sort of inserted into this data. And what the application currently does is it currently just ignores them. But let's say we were running this application and something went wrong, and we want it to just output some errors into like a new sheet over here. So what we would do is we would try to find the code that takes this row and turns it into a transaction, which is something, there we go, something that we represent in the code base. So I'm going to go to here, and here is this function. It takes in a row and outputs some raw transaction data. Don't know what that stuff is, but all we need to do is understand the function by looking on the outside. And the thing is, we want to define what our new functionality would like to be. And so what I'm going to say is, instead of when it outputting nothing when it runs into an error, I want it to output an error when it runs into an error. So either it's going to be an import error, let's say, or a raw transaction data. You'll see some other stuff go red. Who cares? We only care about this function right now, because we only have to care about one individual piece at a time. So what I first have to do is probably define what an import error is. So what I'm going to say is, well, that's probably just like a, I don't know, error message and a line number, let's say. Now, I'm going to open up this function, and I'm going to see a bunch of red. So I have to go in here and get rid of the red. So what this is doing is it's getting in the row, it's getting the cell in the first column. I believe this is zero-based, so the second column really, converting it into a string, and then passing that into a date time, and then converting that into a date only from that date time. Then it's also getting this description, and in this case, it doesn't need to turn it into an option. It's just going to turn it into a empty string if the description is empty. It's going to grab the amount. Again, if the cell is empty, it's going to return nothing. Otherwise, it's going to try to convert it into a decimal, right? And if that fails, it's going to return nothing. And same with the balance. It's going to get the cell. If the cell is empty, it's going to return nothing. Otherwise, it's going to try to pass it into a decimal. If that decimal fails, it's going to return nothing. And then I have a bunch of red here, which is just using this from syntax that I showed you earlier. To get rid of the red, what I'm going to do is I'm going to convert this to an either. This friendly library has created something which, that's bad, allows you to convert it to either if you give it the thing, an instance of the thing that you want it to be when it is wrong. So I'm going to do a new import error, and I'm going to have the message error being date failed to pass. Oh, failed to get date, I don't know. And I'm also going to give it a line number, so I can get the row, and I can get the row number. Then I need to keep it going. Well, I need to do that for this as well. Amount error. And again, all I'm doing is defining the outline of my function and then following the red lines. And I am very surprised to see red lines still.
One bracket short on line 38.
Thank you very much. And the red lines are gone. Very nice. The very nice thing about this is it gives you a red line whenever you do something stupid. And then somebody smarter than you can tell you what that stupid thing was. But again, so now I have just defined my individual module. I don't really care where it's used, but at some point I probably need to sort of actually report these errors. So what I'm going to do is I'm going to try to find the part of the application that actually writes this to a sheet. And it's here. And what I'm going to say is this function, completely independently, I'm going to say, well, let's assume that I have a whole lot of import errors. I really hope I can reference that type that I just made. Nice. And now I'm going to go, okay, well, I just want to write that data to a sheet. And I want to call that sheet, it's called errors. Nice. So now what I'm going to have is a bunch of red. And I just have to follow that red through to actually figure out what's going on. So here's some red. And it says, hey, well, beforehand, you had an option type, and now you have an either type. So instead of just ignoring all of the errors, what I'm going to do is I'm going to call this nice friendly helper method called partition. And that's going to split it into the errors. Hopefully the errors are on the left and the raw transactions. Then I probably want to actually output that somewhere, so I'm just going to chuck it in this structure here. So I'm going to say IEnumerable. Oop. Nice. I'll give that a capital letter, sure. So now all I need to do is put those errors into this output type here. Then I just have to go to my red again. Looks like this is expecting some errors. Now, this is maybe some information that you guys need to know, that I have that you guys don't, is that the raw bank data is here. So all I need to do is call raw bank data dot select many. Where are you? There you are. And this now gives me my errors. Okay, no, I need to actually tell it what it's selecting. X dot errors. And again, we just have to follow the red. This is for the bank SA import. I can't be bothered typing all of that stuff again, but let's imagine that I did, and instead I'm just going to give it an empty list. So this application runs and outputs errors, and I think the only issue is some it doesn't allow you to write unless the Excel things are closed. But if I run this again, I should, in theory, hopefully, see some errors on the sheet. That is not correct. Please don't tell me I'm running it through the LLM. Nice. And hopefully there should be a sheet here called import errors. Very nice. And it has those errors with the error messages for what I had. The general idea is you are defining your problems at the smallest level, you're changing the type signature, and then you're just following the red. And what you get is the ability to do what you didn't think was possible before, which is very nice. So you can probably guess that that is a real-life example of this point number 2 with this fancy from syntax. Here is an example of using this T syntax to, I'm just going to run you through that example, and then I think that should be enough. I was going to maybe run through something else, but we'll try. Do I have this here? Nice. Nope. It's the wrong one. So ChatGPT has a interface a thing called function tools. Essentially, what it does is it allows you to define a JSON schema, and then with that JSON schema, ChatGPT will be able to call that function using that JSON schema, essentially. So the general idea is that you need to, if you have some sort of type that you want to get out of ChatGPT, let's say you have some sort of conversation, you want to define the schema for that type to ChatGPT so it can then write a whole lot of stuff into it, and then you can get that out. So this is an interface, and what it does is, one of the main really annoying things about that JSON schema interface is that if you don't provide a description, it's going to crash the entire LLM. So you need to give it a description, otherwise it's just going to crash everything. That or the library that the C# library that we use to sort of interact with it. So what we have here is something that will go in, look through your type, find all of the different subtypes, and use reflection to generate that JSON schema for you automatically. And we created something called an object description, which is going to a type which takes a name, description, blah, 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 and outputs some JSON. And it's a nested type so that it can output some more JSON and some more JSON, depending on how nested your object is. Essentially, what that allows you to do is you can go into your demo, and you can be like, hey, let's say we're talking to a doctor, and you're like, what's your name? My name is Ronald. How old are you? This, I was born and in 2001, blah, 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 blah. And what I have here is a function which, why is that type signature not a little bit better than that? Using GPT will get from JSON your type as long as that type has an object description. And so when I run this program, we should hopefully see it go through this conversation and figure out that the name is Ronald and that he is born in something, July, 15th of July, 2001, and his age is equal to 23. And so this is fully reusable code. All you need to do is define this whatever interface, and it should hopefully work. So if I do something like record dog name, dog, string name, no, int age again. That might hurt. We'll see. We'll see whether the LLM can cope with it. Dog, dog. My dog's name is Bob. Hopefully what we should see is this automatically, I haven't actually tested this at all, so we'll see, but I'm pretty certain this should automatically give me the dog's name is Bob as part of that object. Or it could shit the bed. Who knows? It was meant to say hello world, wasn't it?
Yeah.
How did it fail to say hello world? Crazy. That's very sad. Oh, wait, there it is. Dog's name is Bob. Very good. So this is only possible because we are using this T syntax. You probably just have to take my word for that. But without the T syntax, the entire reflection sort of toolchain just kind of collapses. So you just need to use it. So here's that other technique for this. What time is it? 7:04. Let's just call it. So there is. This is how you would. I'll see whether this project runs. So this is a game that I made for a friend's box night. The general idea is that you vote on who the king is, and the person with the most votes, their autographs are worth a lot of money. And so your job is to get the autographs of the king, vote for him, and then have a whole lot of money left over from the autographs. So this is just like a quick full stack application written in ASP.NET, and I really hope it runs. The general idea is that what you can do is you can look at individual pieces of functionality and just define the sort of types that actually are what you need for the functionality, and only think about those types without having to think about any other fields. This computer is not the fastest. So of this, you have a game. In that game, you have some players, you have some roles, you have an inventory, you have a shop where you can buy stuff, you have an invitation, so I can invite Jasmine to trade, and then I can log in as Jasmine. Damn it. Because I was just playing this with friends, we just assumed that passwords were unnecessary. I can join this lobby again. I can go into my trade invitations. I can accept this trade invitation and run it side by side with this. So if I accept this invitation, that is not good. Oh, it's breakpoint. Computer, I believe in you. And this will happen. I have a current trade going on, and I can add my items to this trade so that people can trade their individual things. So there's a few moving parts. You can then vote for people, and then if you open up like an admin view, you can then calculate their score based on the points. But the point is, each of these individual parts can just be considered as their own individual type. So if I look at the code base, and this is the code, okay, sure, why not, because I hit the breakpoint. This is the code that handles sort of trade invitations. So all I do is I don't have to consider any other sort of fields in the database or anything like that. All I do is I define something which, has it like a game. What is a game? Oh, it's a full game. Crazy. I must have, for some reason. What is this? The point is that these types here don't contain all of the information of the entire game. It only contains information that's related to trades. So all it has is the user IDs of the people with that are possible users, and the user ID of the people that are in individual trades, and the current invitations. And the current invitations are only the user IDs from and the user ID to. So this is the minimum possible information I can use to implement invitation accepting functionality, which is completely different from trading functionality, which is completely different from shop functionality. I can go in and I can write a whole lot of functions. I'm going to collapse these definitions again, that only interact with these very, very limited types. And then I can use these lenses, which might look disgusting to you, but look very, very beautiful to me, to sort of zoom in and out on my entire game state and edit my game state as I'm going without ever actually thinking about it whatsoever. So when I see this, I don't actually look at this type at all, because all that matters is my individual functions with the very, very limited scope. And because I have a very, very chiseled out sort of scope for my functions, it becomes very, very easy to write these functions, because I can only move, the parts that I'm allowed to move are only the relevant parts. So it's very difficult to make mistakes, because you can't just randomly change a field over here or a field over here. You can only change the field that you're actually dealing with. What also is easy is that these functions are a lot smaller. My mouse has run out of battery, very good. Than otherwise they would need to be. So for example, this is just doing some if logic to check that it is not, that the user actually contains the game, the game actually contains the users, and then just adds the invitation to the trade afterwards. So this is how all of these individual techniques have been used in individual projects. And I think that's pretty much the entire talk. All right. Thanks, guys. Any questions?
So this is probably going to be a weird thing with techniques for anyone, but if you're working on projects with multiple people,
yeah.
Techniques like lenses.
Lenses, not so much. Just give up on that one. I put it as 4. All of the other ones, I'd say one of the big things is this idea of defining a union type. Even though this is not the closest definition, the fact that you've defined it is still useful, and it will influence your code if you just define different unions throughout. Here is just defined as an abstract record. I tend to think that's the best way to define union types if you're trying to code quickly, essentially. If you don't want to deal with sort of people complaining about fancy structures randomly appearing in their code base.
Well, one day they'll have multiple inheritance.
So yeah, apparently typed unions are coming, in which case. So
It's been a formal proposal.
Yeah. So, sometime in the next 5 years, hopefully, is the outside. Yeah. Anyway, did you have a follow-on? I think you can, for example, I think a lot of people are somewhat comfortable with the link library, you'll be able to sort of introduce these types.
Is there a benefit to using the plain text ones over the function chaining version of LINQ?
Yes. So if you go into this function here, the issue is it's really hard to actually function chain something like this, right? Because you have two outputs that you kind of have to keep track of. For example, this, I'm trying to find where it would be. This egg here splits into a yolk and white. You put the yolk here. So these two functions can happen at the same time, right? The inputs of this function will output a lemon filling, but then you want the sugar over here. How do you access the sugar? With the select. Generally, like conceptually, this looks gross a little bit the first time you look at it, but it is actually just literally you just change from there to from and equals to in, and you get the exact same code. You might have a little bit more problems with the debugger, but in general, you don't actually need to use the debugger nearly as much when you have these very simple sort of chains. But yes, so my recommendation for if you ever want to get started with this is that you just take very, very small sections of your code base and try to implement them. And this library over here called language extensions will have a lot of helper methods that allow you to just do things relatively easily. They just have a lot of these pre-built structures so that you don't have to build time yourself. This was me trying to build time. What I actually did was just ask ChatGPT to write it, and I knew exactly how to ask it to write it. But in general, most of the very, very reusable structures are already defined in libraries like result and option, which will come to C# sometime. They're the ones that are in the sort of proposal. And I would imagine they would be silly not to support this syntax when they do include result and option. And when you use result and option quite a lot, you'll eventually get to the point where you're like, hey, actually I am getting the hang of this. Now I can start looking at all of these other sort of structures and how they might be useful. What's interesting is for example, tasks and stuff like that. All of the things that you classically consider very complicated that then got solved by the task sort of thing, they're mainly just solved with these sort of structures. So they just kind of define a select and a select many, and then it just kind of works. I should probably mention the real word is map and bind for these. So if you ever want to ask a computer or go online or check any other language for how they consult how they do it, instead of using select and select many, you have to use the word map and bind. But other than that, it's mostly just the same.
Where does that terminology come from? Where is it from?
Category theory. So category theory is like a branch of math. So this concept of composition, I sort of shortcutted. It's actually if you think about caveman scientists, they came up with the idea of counting. A caveman came up with the idea of counting, where they just took away, so they were I see 3 rocks over here and 2 rocks over here. And I added them together, and I got 5 rocks. And I counted them in my hand, and I got 5 rocks. And then I saw 3 rabbits over there and 2 rabbits over there. And I added them together, and I got 5 rabbits. So they came up with the idea of numbers by taking away the concept of rocks and rabbits, doing some fancy maths over here, and then bringing back in the context. Turns out building small things, big things out of small things is really, really, really useful. So there's a branch of mathematics that's all about building big things out of small things, and it just turns out that pretty much every branch of mathematics sort of falls under this, because it just turns out that every single branch, at the end of the day, mathematics is literally just finding ways to build big things out of small things. So the concept of map and bind comes from this idea that I want my 2-dimensional world to be collapsed back down into a 1-dimensional world, right? And so you kind of take your 2-dimensional world and map it over into your 1-dimensional world. And then if you have some 2-dimensional world that's doing crazy shit, then you bind it over to your 1-dimensional world. So they're very fancy branches of mathematics that essentially stem from this concept of I have 2 things and I want to safely join them together into a bigger thing. And the claim is that you can create infinitely complicated structures from it. Because there's a couple of mathematicians from like the 1900s that did a bunch of proofs, but the general idea is that if you had the ability to write a box that accepts a function and outputs a function, so it accepts a box and outputs a box, then you have the ability to do anything a Turing machine can do, right? So some mathematician just proved it. I can't read the proof. I assume it's correct. Nobody's ever said it's incorrect, so I'm kind of okay with it. But that's just generally where all of these concepts come from. Pretty much all of these structures are just someone has taken some fancy maths and tried to translate it into programming world, because it just turns out that programming is actually quite good at representing mathematics. Also, spreadsheet surgeons, good. Yeah. We take maths and apply it to stuff. I don't know how to run a company, but that's generally it. All right, let's guys.
Yeah. Well, would you join me in thanking Calvin?